Hello my friends, welcome in Meteorological Discussion channel. Lecture number 2, we talked about B&ID, piping and instrumentation diagrams, and piping vents and drains. And you'll find the link of the video in description box. In this lecture, we will talk about and discuss important objects related to piping systems, otherwise power or petrochemical plants. Number 1, insulation, types of insulation material. Number 2, piping calculations related to design. It is design issue. Material selection, piping size, thickness. Okay. Number 3, we will talk about critical piping. What is a critical piping? First, we will talk about insulation, types of insulation, material insulation. Insulation, when hot fluid flows through pipe, then generally pipe is insulated. There are two reasons for insulating the pipe carrying hot fluid. Number 1, containing the heat inside the pipe. Insulation preserves the heat of the fluid, so it is called hot insulation. Number 2, personal safety, so that people don't get burn injury by touching hot surface of pipe. It is called personnel protection insulation. Cold pipes are also insulated. For cold pipes, cold or chilled fluid carrying pipes are insulated to prevent heating of cold fluid from outside. So it is called cold insulation. Sometimes cold pipes are insulated to prevent condensation of atmospheric water vapor on pipe surface. So it is called anti-sweat insulation. It is used to prevent condensation of atmospheric water vapor on the pipe surface. Other types of insulation. When gas flows through pipes at high velocity, it creates noise. In such cases, pipes are insulated to reduce noise. It is called acoustic insulation. Number 2, sometimes pipe and its content are heated from outside by heat tracing element. In that case, pipe along with heat tracing element are insulated to conserve the heat of the tracer. It is called heat tracing insulation. What is the insulation material? There are more types of insulation materials. Number 1, fibrous material, which have large voids full of air between fibers, cork and glass wood, mineral wool, organic fibers. Number 2, cellular material, which have closed void cells full of air, as calcium silicate, cellular glass, it is a foam glass, polyurethane foam, PUF, polystyrene, thermocol. Sometimes cast material like cement plaster or plaster of Paris are also used. Insulation cladding. Insulation materials are generally soft or fragile, so the outer surface of insulation are protected with aluminium sheet or GI sheet cladding. This picture 4 pipes are insulated and general compounds of insulation. Here we see pipe, this tape, here it is a sealant used, insulation inner layer, here this insulation outer layer, vapor barrier, this insulation cladding or jacketing is used from aluminium sheet, as we said, insulation cladding with aluminium sheet, and it's a binding strip. Piping calculations. Piping calculations related to design. If we work on projects power plant, we will use design code ASME 31.1. If we work on process piping, we will work on design code ASME 31.3 for process piping. So the piping calculations related to designer according to design, related to material selection, piping size, schedule or thickness. Okay, so pipe material selection. To select appropriate pipe material based on following fluid property. Find out type of fluid flowing according to fluid. Find out fluid temperature and pressure according to temperature and pressure. After that, check pipe life expectancy. Select suitable material per practice note number one. Note number one say material is selected per past experience with cost in mind and per material listed in design code. If material isn't listed in code, may select next suitable material listed. After that, check material listed in design code. If yes, the material okay. If no, see note number one as we said. Number two, piping calculations according to piping size. First, material selection. Number two, piping size. To select required pipe diameter based on velocity and pressure drop. According to velocity and pressure drop, find out flow volume per second. Check velocity allowable per second. Calculate flow area required and pipe size. Pressure drop for the pipe size. Check pressure drop meets pressure budget. If yes, pipe size okay. If no, increase pipe size according to pressure drop. Number three, according to pipe thickness. As we said, pipe divided by schedule, and it differs from nominal pipe size to another according to schedule. To select appropriate pipe thickness based on flowing fluid property, select material diameter as we said here. Find out fluid temperature and pressure. Decide on corrosion allowance. Pipe thickness per code according to design code. Note number two. Note number two say S&L had a standardized set of piping materials suitable for various fluids and various service conditions according to service condition. These are called piping design table, PDT. It is piping design table. If calculated pipe thickness don't match with standard PDT, project specific PDT are created with PDTS software. It's piping design table software. Check if S&L PDT piping design table matches requirement. If yes, selected PDT for project. If no, create new PDT for project by PDTS software. Created new PDT for project. Piping design table and valve design table, PDT and VDT. For piping design table and valve design table, S&L has standardized sets of pipe and valves grouped based on various applications. These sets are called PDT piping design table for pipes and fitting, and valve design tables for valves. These tables in their physical data are considered in Blades database. When we create piping 3D model by using PDWP piping design workbench software, all pipe and valve data are fetched from database and automatically inserted in the piping model based on the PDT selected piping design table. While we select pipe or valve material for any intended service, we try to select the best suited S&L PDT already available in the database, Blades 2000 database. If in any case we can't find a suitable match, we have to create a new project specific PDT or VDT according to project design. This creation of PDT and VDT is done through PDTS software, piping design table software. The created design table is reviewed and approved by authorized person. As it is approved, Blades database is updated and the new PDT can be used in the generation of piping model to create 3D model. Now we will show sample for PDT. It's a sample for piping design table. Here we see the PDT for project, specified for project, service and line material, liner material, nominal rating according to ASME class 150. Here we see minimum size, maximum size in the type butt weld or socket weld, joint detail, welding requirement, process detail or smell. Here we see pipe, fittings and flanges. Item here pipe, here fitting, here outlet fitting, here flange. So minimum size, maximum size, rating, dimension standard according to standard, manufacturing specification, general description. As we said, this for specified for project. Critical piping. What is a critical piping? In power plant, In power plant there are some piping which carry steam at high pressure and temperature, and also there are piping which carry water at high pressure. These pipes carry the main cycle steam and water of the steam power plant. In power plant we need material can withstand high temperature, like alloy steel material as 9% chrome and 1% molybdenum. It's called P9 material, P9, P91, 92. It's used in power plant because it is withstand high temperature and it is creep resistance material. These piping are called critical piping. Very special care are taken to design for this piping. First, the pipe material selection for such piping is very important as it has to withstand high pressure and maybe also high temperature. As these pipes carry the main system fluid of the power plant, they are given the right of way and routed at the beginning of the overall plant layout. For steam pipes run at very high temperature and the hot pipes expand. We have to build in flexibility in the high temperature pipe routing, so the expansion force is absorbed within the piping. Also, there should be enough flexibility. Flexibility is more important. There should be enough flexibility in this piping routing so that high loads aren't transferred to the nozzles of turbine or pumps. There are many recognized international codes which lay down guidelines and mandatory requirements for design of such piping. These codes is ASME B31.1 Power Piping Code. Finally, with the next video, and we'll continue and explain another objects related to piping systems. Thanks to all. Goodbye.